how to write and balance redox equation. How to write and balance redox equation. Writing and balancing redox equation. First of all, you must understand that a redox equation is an equation that involves both reduction and oxidation, both reduction and oxidation occurring simultaneously. So a redox equation is one that involves both reduction and oxidation occurring simultaneously, which involves the presence of a reducing agent and an oxidizing agent. Okay, now we're going to be writing a simple redox equation, one that involves a reaction between FeSO4, known as iron 2 tetraoxophase, reacting with KMnO4, which is known as potassium tetraoxomanganate 7, which is usually acidified in concentrated tetraoxophase 6 acid. Now, to react this reaction, this should proceed to give us some products. To be able to determine the product we form, first and foremost, you must know what the oxidizing agent is and the reducing agent is. Now, the oxidizing agent in this case is potassium tetraoxomanganate 7, while the reducing agent is iron 2. Reducing agent is iron 2 tetraoxosulfase. You may be wondering, how did I come about that? Okay, now I would like you to know one thing. In order for you to be able to choose your oxidizing agent and your reducing agent, you must do this. First of all, identify the ions involved. Now, the ions involved in this reaction are, we have Fe2+, which is iron 2 in the first, and then we also have K+, there we have Mn7+, manganate 7, we have O2-, which is oxide, we have H+, and we have SO4 2-. So the ions involved there you can see the ions involved there. Of course, only two of them are transitions. What are those ions? They are iron 2 and iron manganate 7+. So since these are the only two ions that are transition, and to be able to choose which of them is oxidizing agent and which is reducing agent, please look for the one that is more electron deficient. Manganate 7+ means is deficient of 7 electrons, while 2+ for iron 2 means iron 2 is deficient of just 2 electrons. So the one that is more electron deficient is the oxidizing agent, that is, it undergoes reduction. So this is the oxidizing agent because it's more electron deficient, while this is the reducing agent because it is less electron deficient. Now the next step is to identify what the reducing agent is going to be oxidized into. Now, of course, what are the possible oxidation states for iron? They are 0, +2, +3, and of course those are the common oxidation states, +2 and +3, which means iron in this case will be oxidized to iron. Okay, which means iron is going to be oxidized to give us let's say Fe3+. Then manganese will be changing to manganese 2+. That's 2+. That's the one of the stable oxidation states. So that means iron is going to be oxidized to iron 3, and of course, which means at the products, in the product side, I'm not going to be having any more of iron 2. Not going to be having any more of iron 2. So let's remove that, and they are not going to be having any more of ion manganese 7. So what we're going to be having now are as follows. The ions involved are as follows. They are, we have ion 3, then we have manganese 2 plus, then remember oxide, remember H plus, and SO4 2 minus, of course SO4 2 minus, and we have K plus. So just do your cross multiplication between positive and negative ions. Ion 3 sulfate will be formed, that's positive and negative. Manganese tetraoxide 6 is going to be formed. Then of course H and OH to form water, and then the last is this positive and this negative as well to give us that. So that's the affinity we have. So the ions, the compounds that will be formed in the product are as follows. We have the ion 3 sulfates. Please cross multiply the valency to be able to write the formula. Then plus what's going to be formed is manganese sulfate, manganese tetraoxosulfate 6. Then plus what else is going to be formed is potassium tetraoxosulfate 6. Then we're going to be having water, H2O, that's water. Okay, now finally we'll be able to write the products form. Then the next step now is how to balance. Now to be able to balance the Redox equation, now that we know the oxidizing agent and the reducing agent, let us write the half cell equation, where ion 2 oxidized to ion 3 by an electron loss, while manganese 7 was reduced to manganese 2 plus by 5 electron gain. So if you look at this equation, you will discover that this half cell reaction is not balanced. We have 5 electron in the manganese half cell, and then in the ion 2 3 half cell we are having just 1 electron here. So the equation is not balanced. So balance it simultaneously. This is times 5. To make the electrons balance, this should be times 1. So times 5 in the power we have multiply all through by 5. Why this multiply by 1? That's what it is. Now that you have known the half cell equation balance, so you can now bring it to the real Redox equation. So in front of ion 2 we have 5. So in front of ion 2 put 5 there. Then in front of ion 3 you also have 5. In front of ion 3 put 5 there. So in front of manganese 7 we have 1. So it's already 1 here. So we don't need to put 1. 1 is insignificant in the Redox equation. So the next step we're going to do is after inputting these figures, they now try to balance, check if it's not balanced. So we'll now try to balance after inputting the correct electron loss and gain for the oxidizing and reducing agents. Okay, now looking here, you discover that we have 5 Fe. Here we have 5 times 2 Fe, which is 10. So Fe is not balanced. To balance your Fe, what you can do is to we're going to erase this 5 here and replace it with 10. So we're going to replace it with 10 so that it's now balanced. Now ion is balanced. The next thing that we'll try to balance, the next compound that we're going to try to balance is let me clean this. Now the next equation we're going to try to balance is the next compound we are going to try to balance should be the next positive, which is potassium. Now potassium is 2 here, potassium is 1 here. To balance it up, so we'll just try and put 2 in front of potassium. Now potassium is balanced. Now the next we can try to balance after potassium should be, the next is a positive is manganese. Manganese is now 2 here, so make manganese 2 by putting 2 in that other part of the equation. So manganese is balanced, potassium is balanced. The next positive elements to balance is sulfur. We have 10 sulfur here. That's sulfur in 10 places. So 10 sulfur here, and then we have sulfur has 1 here, which is total of 11. Sulfur is 11. Let's check that of the other part of the equation, the product size. Sulfur in this equation is 5 times 3, which is 15. Hope you know it's 5 times 3, which is 15. Then let's look at sulfur in the other parts. We have 2 sulfur in this equation. We have just 1, which is total of 18 sulfur. So sulfur is not balanced. So how can we balance sulfur in the first part of the equation, which is the reactant part? Now we have 1. Since we are having 1 sulfur here, we can change that by making sulfur 8 here. So we'll now be having 8 plus 10 as total of 18, which means sulfur is balanced. Now sulfur is balanced. Let's go to the next electropositive element, which is hydrogen. Now hydrogen is, what is hydrogen? How many is it? Hydrogen is 8 times 2, which is 16 here. Then hydrogen is just 2 here. So we're going to be changing that now. We're going to be changing that of hydrogen now, trying to balance it up. Now balancing hydrogen, since we will just have 2 there, I'll make it this way, putting 8 here. Hydrogen is now balanced. Now we are going to balance the last element, which is oxygen. Let's see if oxygen is not balanced. I think oxygen is not balanced anyway. I think it's balanced anyway, since we'll be following it in decreasing electropositivity order. So I have 10 times 4 here, which is a total of 40. That's oxygen. 4 times 10, 40. Then oxygen here we have 4 times 2, which is 8, plus oxygen here we have 8 times 4, which is 32. That should give us a total of, what is 40 plus 8 plus 32. That should give us 80. Now let's see if it's 80 in the second part of the equation. Here we have oxygen 4 times 3 times 5, which is 4 times 3 times 5. That should give us 60. Then here in these other parts of, we have 2 times 8 oxygen. That's 2 times 4 oxygen, not 8. 2 times 4 oxygen. 2 times 4, that is giving a total of 8. And then here we have oxygen as 4 here, plus oxygen as 8 here. So what are the total? We have 60 plus 8 oxygen plus 4 oxygen plus 8 oxygen. That is giving us a total of 80 oxygen. So you can see that the equation is now balanced. Balancing redox equation is very easy. All you need to do is to identify the oxidizing agent and the reducing agent. Once you're able to identify the oxidizing and the reducing agent, it simply means that the equation is already balanced. All you need to do is just to alter the coefficients and balance your equation at the end of the day. Okay, if you find this video useful, I would like you to please click on the subscribe button to learn more facts.